Hey, this is Pre-Cal Lecture 7.7, and we're going to learn how to evaluate determinants of a matrix, and then we're going to be able to use those determinants to solve systems of equations and also to find areas of polygons. This lecture will be divided into two parts. So this is 7.7 part 1. 7.7.1 is evaluating two by two determinants. All right, a little bit of vocabulary here. Determinant is a number associated with a square matrix. Okay, it's got to be a square matrix. A square matrix has the same number of columns and rows. So 2 columns, 2 rows, 3 columns, 3 rows, etc. The numbers in a matrix are called elements. And determinant notation if you're asked to find the determinant, you'll see something like this, DET for A. That's saying find the determinant of matrix A. Or something like that. So it looks like the absolute value symbol, but if you're working with matrices, you know that you're not trying to find an absolute value, you're trying to find the determinant of a matrix. All right, so our first example is find the determinant of matrix A. And matrix A is equal to 5, 3, 8, 5. All right, so you want to think of this in terms of diagonals. Okay, you're going to do the left diagonal, meaning I'm going from left to right. So it's the left diagonal. And you're going to then subtract the right diagonal, going from right to left. Right, so the determinant is 5 times 5, that's the left diagonal, what I've drawn in purple, minus 3 times 8. So that's 25 minus 24, and so the determinant of this matrix is 1. All right, give you a second to pause the video. Okay, let's do another example of a 2 by 2 matrix. So we want to find the determinant of matrix B, where B is equal to 1, -4, 2, 10. So I'm not going to draw the arrows this time. It's going to be 1 times 10 minus -4 times 2. So that's the left going from left to right minus the right diagonal, right to left. Okay, so that's going to be 10 plus 8, which is 18. Let's do one more 2 by 2 example. This is a special matrix. We want to find the determinant of matrix C, or you could write it like that, where matrix C is equal to 2, 6, 1, 3. Okay, so the determinant is going to be the left diagonal, 2 times 3. Minus, we're going right to left, minus 6 times 1. So that's going to be 0. And that's a special matrix when the determinant is equal to 0. We call this a singular matrix. Singular matrix. All right, so that's 2 by 2 matrices, pretty easy. Gets a little more complicated when we go with 3 by 3 matrices. So we'll try a couple examples and a couple of different styles of determining the 3 by 3 determinant. All right, section 7.7.2 is evaluating three by three determinants. Okay, the first way that I'm gonna teach you how to do this is the diagonal method. In your homework, you will be asked, I'm gonna show you 2 different methods, and in your homework, you'll be asked to do it both ways. So make sure that you use the method that the question tells you to use. So what we're gonna do first is sum the 3 left diagonals. Okay, so here's our matrix, our example. Find the determinant of matrix A, and matrix A is 2, 1, 0, 3, 1, 4, and 1, 1, 2. All right, I'm going to use a couple of different colors to show you the 3 left diagonals. Okay, so diagonal 1 is just right down the center. Okay, we'll call that diagonal 1. Diagonal 2 looks like this pattern. And then you come back and get this single number that's left. So let's call that diagonal 2. Okay, and then diagonal 3 be the one that's left. So okay, hopefully you can recognize the pattern here. Okay, so for diagonal 1, I've got 2 times 1 times 2. So that's 4. Diagonal 2, okay, that's the one in red here. 1 times 4 times 1. So that's 4. And then diagonal 3, I've got 3 times 1 times 0. So that's 0. Add that up and you've got 8. All right, now we want to sum the 3 right diagonals. So I'm going to rewrite this matrix. 2, 1, 0, 3, 1, 4, and 1, 1, 2. We're going to do the same thing. This time we're going to be coming from the right. So diagonal 1 is the one that is right down the center. Diagonal 2 right, and then diagonal 3 would be like that. And it doesn't matter if you get 2 and 3. You know, if you call what I call 3 2 and what I call 2 3, that really doesn't matter. So diagonal 1 is 0 times 1 times 1, which is 0. Diagonal 2 is 1 times 3 times 2. So that is 6. And then diagonal 3, 4 times 1 times 2, which is 8. So the sum of those is 14. All right, so to get the determinant of this matrix, you're going to take the left sum. Let's write this here. Determinant is equal to the left sum minus the right sum. Left sum minus right sum. So 8 minus 14 is going to be negative 6. All right, so that is the diagonal method. Now I'm going to show you a different method called the row-column method. I'm going to use the same matrix, and we'll see if we get the same answer at negative 6. We certainly should. If not, did something wrong. Okay, so I'll give you a second to pause the video and get all that written down. All right. Okay, and the next method, which should give us the same answer, is called the row-column method. Okay, so we're still in 7.7.2. So we want to find the determinant of A. And I'm going to write down the same matrix I wrote before. So it's going to be 2, 1, 0, 3, 1, 4, and 1, 1, 2. All right, so our determinant should be -6. What you do with this method is in the x column put a plus, and then the next column put a minus, and then the third column put a plus. Okay, that's going to help remind you how to put all this together. So what you're going to do, and I'm going to do this in purple, is for our first column, I want you to circle that number, and then you're going to mark out, let me do this really lightly so I can erase it, the first row and the first column that number is in. So what you do is, see what's left here is a 2 by 2 matrix. Okay, so I'm going to put a scalar out front, 2, times the matrix that is left right here, 1, 4, 1, 2. So that's going to be positive 2, got a plus there. Okay, so let's see if I can. Okay, so for the middle column, we're going to work with that number 1, and I'm going to mark out the column that 1 is in and the row that 1 is in. So you're left with the numbers not marked out, the 3 and the 1, and the 4 and the 2. So it's a negative above that column, so -1 and 3, 4, 1, 2. And then the third is going to be 0. Okay, so that's going to make this entire section 0, but I'll go ahead and show you how to do it in case you work one where it doesn't have a 0, which is most likely. Okay, so the 0 is our scalar that we're going to multiply, and we're going to mark out the row and column that 0 is in. And the matrix, the 2 by 2 that is left, is these 4, 3, 1, 1, 1. Okay, so now you will take the 2 by 2 determinant. So we have this 2 out front, and we'll get the determinant of this 2 by 2 matrix. 1 times 2 is 2, minus 4 times 1. 2 minus 4. Left minus right. 2 minus 4, -2. Minus 1. 3 times 2 is 6, minus 4 times 1. 6 minus 4 is 2. Plus, we've got 0, 3. 3 times 1 minus 1 is 2. So that's going to be -4 minus 2 plus 0, which is -6. So that worked out for us. The diagonal method and the row method matched. Okay, so sometimes you get to use whatever method you prefer, and sometimes you're told which method to use. So that concludes the lecture for 7.7 Part 1. 7.7 Part 2, which I will do in a different video, shows you how you can use determinants of matrix to calculate areas and things like that. So I'm going to give you the first part of homework 7.7. Okay, I'm going to give you the answers to 1 through 7. Okay, so I'll let you pause the video if you need to write any of that down. All right, the answers to homework 7.7, number 1, -10. Number 2, -4b plus 3a. Number 3, -2. Number 4 is 0. Number 5, -2. Number 6 is -8. And number 7 is 16. All right, so those things that we learned in this lecture, you can do 1 through 7, and the next lecture I'll show you how to do homeworks numbers 8 through 11. So that includes lecture 7.7, part 1.